Okay, so I think we can start with a bit of more of Conan. Um, so I think it's a typical start for any Conan presentation that, as I mentioned, that the person presenting is not associated with Conan, and as my previous speaker said, that this is not an official Conan presentation. I'm just a Conan user. And my goal for today is to show you how we, as developers working in KP Labs, are using Conan and how we structured our environment to facilitate working with Conan packages. I will be not introducing Conan concept to you, but luckily we all had quite good introduction into Conan just before. So I will actually base on the ideas, and note that a few code samples I had on my slides are a bit simplified, so they will fit on a limited screen space. But they show the main idea behind what I'm talking about. So a bit of background. I'm working for company KP Labs. It's a company working in space industry, and I'm working in team that develops flight software for small satellites. So our targets are mainly bare metal microcontrollers like ARM Cortex-M3, R5, or recently microblazes. We are using modern C++ with CMake, and we can limit ourselves to that toolset. We are relying on a lot of cross-compilation, even for unit testing, where we are using QEMU to run unit tests. So we are using many toolchains on daily basis. And because of constraints of our platforms, we are limited to static and header-only libraries, which solves or actually removes a few problems from us. But to complicate things a bit, we are using a lot of Python tooling around our C++ code. I think most of components we developed in C++ has some corresponding Python tools and libraries for working with. And our team now has 10 people in it, and we are sometimes we are working with like 6 people on a single project, so there are a lot of dependencies between each other. Okay, before we started our journey with Conan, we had our main project, which was development of flight software for onboard computer for Intuition 1 mission. And we had most of our code in single monorepository. From the beginning, we knew that at some point in time we will have to split that repository into smaller pieces. So we took care of structuring that repository as well as possible, but it's still a single repository, so it's not very easy to reuse in other places. From the beginning, we are using fetch content, so built-in CMake capability to pull in a few dependencies, starting with GSL and few internal libraries. Most importantly, it's our C++ wrapper around FreeRTOS and terminal library. These are slowly changing libraries that had few revisions over the years, so fetch content was good enough to pull them in. Problem is that as company grew, there are more projects coming for us in near future, and there are a set of nice components in Intuition 1 OBC repository, and they are reasonably well decoupled from other other components. But to use them, we will have right now we will have to pull whole repository and extract different parts from it um, to get just single component. So it's not very easy to use. Splitting that repository and dependency management with fetch content is doable, but managing dependencies and especially transitive dependencies with fetch content is not very easy and straightforward to use. There will be a lot of manual work to make this work. And also there is a possibility from the company point of view that we will be packing our libraries and providing them to external teams, to our customers, and we would like to share them as binary only libraries, so header files plus static libraries for use in projects that our customers are developing. So we need to split our repository into packages, and to give a bit of scope what will fit into single package. These are few examples of what can package contain. So we can have a package with single functionality like scheduler module or scripting engine built on top of Lua, or telemetry management module. Device driver for module bought from some suppliers is also separate package. So we can have package for communication module or some power module. We are using a lot of CMake in our project, so packaging some CMake utilities, for example, for working with Intel hex files, would be nice to have them as reusable components. And of course, some general purpose utilities like base64 encoder or CRC calculation, stuff like that, and would like to have them as separate packages. If we look into more complex package like scheduler or device driver, we can see that there are actually more things that pure functionality inside that package. Because I would like to add some unit testing support in case of more infrastructure-like components. It is nice to provide pre-built mocks for Google Test or some matchers to simplify unit testing of application by end users. We have embedded terminal that is very easy to bring up on top of, let's say, UART link. And by providing ready shell commands for that terminal that are built for specific, let's say, device driver, gives a nice experience for package user. The same goes for telemetry management. So if you are building your flight software, you want to have some telemetry, and you would like to get telemetry from different modules. Similarly, if you have a large enough MCU, you can use a scripting engine and integrate different modules for different devices, so the user of your satellite can run different scripts by using these modules. What's important is that beside the functionality itself, all other features are optional. You shouldn't be forced to use, let's say, telemetry integration if you don't want to use telemetry integration because you are building just like a laboratory experiment for talking with some devices. In more graphical form, we can think of our packages in, let's say, in this way, where we have a single consumer project which pulls different dependencies. We have some standalone libraries like base64 encoder, and library with embedded terminal, scripting engine, or telemetry management module. And communication module driver has different components that depends on different infrastructure like components. but you as a consumer, you select which components you want to use and which dependencies will be pulled into your project. So the opt-in capability is very important for us. To solve our problem, we have a lot of infrastructure built over the years already in KP Labs. So we are using Jenkins with a lot of Jenkins files and pipelines. We are using self-hosted GitLab for all our repositories, and because it is self-hosted, we can structure our groups and subgroups very freely, so we can build nice structures there. Because of Python tooling, we already have Nexus for sharing these packages. And from the start, we built mechanisms for automatic toolchain settings distribution. Settings like Nexus URL, so there is no global Confluence page with different URLs you need to know and configure manually. There is single repository you can pull in and get all URLs as CMake variables, so that is pretty easy to use. The same goes for toolchain. We have a mechanism that packages toolchains into zip files, and you can just download and use in projects. And this toolchains contains toolchain files for CMake with different with definitions of different platforms. So we can rely in other projects on these toolchain files being somewhere. And all of this is automated, so all our CI nodes are updated with recent settings and toolchains. We looked at different solutions when it comes to packaging in C++, and decided to go with Conan because it's it supports C++. It supports binary distribution, so it's important from the business point of view. We can use per package options to opt in or opt out from different subcomponents of package. Let's say we can disable telemetry integration, and we can pack these different different submodules, subpackages into components, so we don't have to multiply packages and have separate packages for telemetry integration. For communication model, we can have a single package with different components in it. That greatly improves the maintenance of packages. And Conan is also very flexible when it comes to creating and using packages, so we didn't have to throw away all our development flow, and we were able to plug it into our development flow. Okay, so first thing we did when we started with Conan was to customize settings schema. We did it to customize two things. First was to describe architectures we are working with. So we added explicit entries for Cortex-M3, Cortex-R5, microblazes, and a few others. And we added section to describe FreeRTOS settings. And we described these settings in terms of sizes of RTS structures. So size of task, size of mutex, size of queue header, and stuff like that. We're not specifying individual RTS features inside RTS, because you can then customize FreeRTOS and different features in FreeRTOS in end-user project, and you can use different settings as long as these sizes matches. To avoid talking about individual settings, we are treating profiles as, let's say, units of settings that you are using in your daily development to specify how packages shall be built. And projects shall not modify individual settings. So no project shall modify, let's say, ArcMCU setting. The only exception here is setting build type, because creating profiles for a build type is not not something that makes sense. In most packages, you will have to specify two profiles, one that defines platform, so MCU target, and another that will specify RTS settings. That allows us to reuse different set of RTS sizes between platforms. Also, to simplify development, our profiles, the base profiles defines path to CMake toolchain file. So the only thing you need to care about when developing packages is specifying proper profiles, and everything else will be linked properly. Small snippet from settings YAML. We have added section for RTS settings with sizes, and added architectures for ARM Cortex with different subtypes and microblazes, and potentially others in future. In base profile, there are three things worth mentioning. So first is definition of architecture and compiler. So this is profile for Cortex-M3. Second thing is build requires section that provides package, allowing us to transparently build different packages for different platforms, and provide glue between package and QEMUs. So in this case, in Oryx generic Cortex-M package, we will have startup files for Cortex-M3 that will allow us to build executable that can be executed in QEMU. And the first thing, I said that our profiles specifies toolchain files. So here we set the Conan CMake toolchain file variable, and this thing is actually a CMake variable, that is replaced automatically by some script that copies profiles from shared repository into your Conan home. And this variable is replaced by full path to your ARM Nuna-ABI toolchain folder, where a Cortex-M3 CMake file is located. So this profile provides you everything you need to build single package. RTS profile is pretty straightforward, just a bunch of numbers to specify different sizes. Actually, pretty boring at this point. Okay, when we look at the single package, we try to keep single package in single repository, and right now we are keeping all packages in single GitHub group, where they are automatically picked up by Jenkins, so there is no need to manually configure any builds. I think that in near future we'll need to split this group into several subgroups to make it easier to browse, but right now it's enough. And in package there are a few files that we rely on to build package correctly. So starting with CMake list, so we can actually build package and provide artifacts, which are collected by a Conan file, which orchestrates package building and describes how consumers can use this package. Next thing is build.py, which is a simple wrapper around Conan package tools to build different combinations of package. And everything is wrapped in Jenkins file, so our CA server will know how to build. Starting with CMake lists, nothing really fancy here, just a typical modern CMake, where we are using install commands to output the artifacts for our package. And we are using a custom destination directory for header files, so we can separate headers from different components, so they will not mix up between components, and you will not be able to include file without corresponding static library. For unit tests, we are using just executables with small plot twist, because in case of building for Cortex-M3, you will not be able to run your executable directly. We need some form of emulation. And because we don't want to tie our packages to a specific platform, there is a hook or convention that allows a toolchain file to specify target emulation function that will set up a given target to be able to be executed under QEMU. So it will link some additional libraries from this generic Cortex-M package that will provide a startup file, and it will also set up cross-compiling emulator inside CMake for this target to be able to execute this binary under QEMU. And after that, we can use gtest discovery to plug our unit tests into ctest infrastructure, so we can use ctest everywhere and we are independent from platform we are working on. Yeah, the things I just mentioned. And once we have CMake list, we can go to Conan file, and this time starting from the bottom. We have three functions for integration with CMake, so package, build, and configure CMake, where we are using CMake helper to generate build and install package. We are using install artifacts as our package artifacts, and if there are any options that needs to be passed to CMake, we are passing them as definitions, and we are trying to keep this passage of options as simple as possible, to not to put too much logic into Conan file. So typically it's just passing Boolean values are as options. When it comes to versioning, we are using set version and dynamic version generator, which is based on our different Python package that generates a version based on Git history. I will talk about it in a few slides. But important thing here is that versioning is automatic for Conan packages. To not include source files with package, we are using SCM with automatic repository discovery. So sources are not included in package, and if you'd like to build package on demand, you will have to fetch sources from GitLab. Okay, when it comes to package info, we have a rule to always use components, because for most of our packages there are more than one component, typically 3 or more. So by using components, always it's just easier to follow and extend package later. At the start, we decided to customize target names and file names for find package a bit, so they will look nicer. So we are using set property with CMake target name and CMake file name to customize these values. But in perspective, I don't think that that was a very good idea, because it is a bit confusing, especially for newcomers. So I will advise you to not to use these properties. We are sticking to them just to avoid even more confusion and inconsistent package names. If there is an optional component, like script module I mentioned at the beginning, you can opt in to use a script module by setting option. And if you enable this option, you will get additional component with a script module definition and additional include directories. Important thing for components here is to limit requires to specific components, so we will not get, for example, Google test by mistake for your target that is executed on MCU, because yeah, that's kind of risky. And optional components can be hide with options. BuildPy is a Python script that is responsible for building different combinations of packages. It is built on top of Conan package tools, which provides Python API for building packages. We've wrapped it into API that makes building script a bit shorter, and we embedded a few versioning rules, and let's also remote URL, so there is no need to put it into every recipe. And here we are building a Conan file linking repository with 6 different option sets. So this dictionary defines all combinations of packages that you would like to build. And then using just 4, we are adding different sets to packager, and Conan package tools will then build all required sets. And this script is invoked separately for each profile you would like to build, which will be shown nicely in Jenkins screenshot in a few slides. Important thing to note here is that if you are using full options in package ID method, you need to include options for your dependencies in this dictionary, so you'll get proper binaries built. I will not torture you with Jenkins file syntax because it's not very nice, and especially too big to show on slide. But this is the screenshot from Jenkins UI. We've built of one of our packages. We have a matrix build with axis for each profile that we are building. As you can see in this awesome UI, there are different profiles specified here. But yeah, actually there are different profiles built on potentially different machines. They are selected based on nodes on CI, where packages built is selected depending on profile. So for example, we have a machine that builds Visual Studio binaries. And in each branch, we are building unit tests and running them. And then we are building packages basically just by running build by script. And everything is each packages from each build are uploaded to Conan server. And this build happens on all branches, including feature branches, so we have easy access to development version of packages. If you are working with more extended Jenkins file, I would suggest you to use Jenkins pipeline library to simplify scripts a bit, and especially to separate your infrastructure stuff from the core functionality needed to build your package. So for example, toolchain directories are embedded into Jenkins pipeline library, which is part of infrastructure, and our Jenkins file just says that, yeah, I need Arnon Yabi toolchain, just give me it. Versioning is not an easy topic. We had few approaches to solve that problem, and we decided we gave ourselves a bit of goal for versioning strategy we like to use. So first, it needs to be low effort in when it comes to releasing packages, and you need to follow semantic versioning. Also, it would be great if we could get something that works both with Conan and Python, because Python versioning is very similar to semantic versioning, but there are few syntax differences. So, for example, using setup tools SCM with Conan will give you packages that are not Semver compatible. So, a bit of problematic situation. We decided to go with conventional commits to describe type of changes made to repository, and we based our solution on Committizen with slight modification that each each commit on master branch is given a stable version number. So if you merge pull request with 3 commits, each including minor change, so let's say feature, it will bump minor version by 3. That gives us very stable version numbers and easy to follow, and independent from how commits are merged into master. What is important is that there is no need to manually tag repositories with release tags. Releases are done automatically, so one can say that we applied continuous delivery to development of space software. And for feature branches, version numbers are generated in the same way, but they are marked as pre-release with -dev suffix. We have a rule that Conan file py is part of package, so if it is modified in a way that can be inspected by consumers, a package should have new version number. So if component is added, it's a feature change. If component name is changed, it's a breaking change and major version shall be bumped. That solves a lot of problems. We don't have to deal with stuff like recipe revisions because package version is enough to point to a specific package instance. To separate stable packages from feature branches, we are using 2 different channels. So master branch is uploaded to kplabs/stable, and feature branches are uploaded to kplabs/devel channel. For daily work, if you are working with a package, then your entry point to working with this package is Conan, and developers shall use commands like Conan install or Conan build to build package. That way we can ensure that if package needs to be built on demand, Conan will be able to build that package. So you should also not use CMake directly to avoid any kind of different states of build directory. We decided to go with ctest for unit testing because it gives us consistent interface for running unit test independent from base platform we are working with. Yeah, because it's easy to run, let's say, Google test compiled on with Visual Studio because it's just running exe file. But for unit test build on Cortex R5 platform, it's a bit harder because QEMU needs to be spun up to run ELF file. With ctest, we have a consistent environment, and recently I even plugged in PyTest as ctest unit test just to get um, inconsistent interface. Also, we are not using log files in packages, and we are relying on version ranges and semantic versioning of dependencies. So if you're building package, you will always get newest possible version of all dependencies as long as they match your version numbers. Situation is a bit different in context of consumer projects. So the end user project that is built for specific platform. Then your entry point is just CMake, mostly because there are always few toggles that you would like to switch during development, and using Conan file py just to pass these values to CMake is just adding pointless layer of abstraction here, especially if the Conan is integrated into CMake lists by CMake Conan integration. And for example, profile is hard-coded into CMake list because your project is built for specific platform. Yeah, it's project running on Cortex-M3. So we can put that information in CMake list. To get some level of reproducible builds, we are using base log file in consumer repositories. Base log file store only version numbers of dependencies, and full log file with expanded package ID is generated on the fly during CMake configuration stage. We are not keeping full log file in repository because with different toggles you can switch in CMake that affects options of different packages. You will have to manage something like 16 different full log files in single repository, which is not very feasible to do, and just a noise in a repository. Right now we have over 40 repositories with different packages, and this is just half a year of development, and we are adding new repository every, I think, week, or maybe something less. Our Conan server, and we are using Python Conan server, is hosting over 700 of different package versions with almost 9,000 of different binaries, taking 20 gigabytes of disk space. I was a bit shocked when I saw the disk space usage a few days ago. But yeah, the Python Conan server is handling that kind of load nicely. We didn't have any problems with it, so it's a good solution for start. So after this month of usage of Conan, there are few things worth mentioning that let's say that are a bit problematic for us, and I would like to share that with you so you are aware of these issues. So first thing that you will probably hit pretty early in your Conan development is that sometimes the calculated package IDs will be different than what you have in your Conan server. Yeah, that happens because you messed up your settings or options. Yeah, that happens. But the problem here is that it's pretty hard to debug why package ID is calculated differently because it's just hash of some text values, and there is no way to get access to these rough text values. So you can't just open text file and compare it with, let's say, 20 different packages you have on server and compare which value is not matching. And you need to do a bit of guesswork. To be honest, on a few occasions I put some prints inside Conan code base to get these text values, and put it into KDIF. But after a few months of work, yeah, the problem was a bit reduced. I think mostly because we were more aware of how different packages are combined together, and were able to uh, build proper packages at the start. Thing that hit us pretty hard in December was that Conan Center packages can break without version change. What happened was that GSL package, which was the only package we pulled from Conan server, was updated, and new recipe was uploaded with the same version number, and it forced us to upgrade to Conan 1.44, which deprecated or changed the way CMake target name properties are used. So all of our target names changed. So nothing was able to link again. And after fixing all these target names, I realized that there is a bug which broke the escaping of linking flags in CMake depth generator. So Conan 1.44 was totally broken for us. And that was the point when we decided to disconnect ourselves from Conan Center and host previous version of GSL on our own Conan server. To be honest with you, I understand why that happened. Conan Center is packaging, it's just distributing different packages with their own versioning schemes, and they can't just arbitrarily bump version number because recipe is changed, something we can do with our own packages. But yeah, that happened, and it caused a lot of trouble for us. And Conan proposed to use log files that keeps recipe revision ID to shield ourselves from this kind of problems. But there are a bit of problem with this solution because base log file contains only package version, and if you'd like to use full log files which contains both package ID, so specific binary we would like to use, and recipe revision, there will be tens of different full log files in each package repository you will have to update every time you update each any dependency or even transitive dependency of package, and we have dependency chain with 6-7 packages long, so you will have to go through each package in chain to update it. So that's a bit of maintenance nightmare. And if you'd like to use log files in packages, you will be not able to build your package with updated dependency without going to the repository and updating log files. So a lot of manual work that needs to be done just to prevent ourselves from Conan Center breakages. So we decided to disconnect from it. A bit related to that is that if you go through Conan documentation and presentation link on GitHub, you will notice that the approach to CI builds envisioned by Conan is a bit different from what you might expect. And right now we are at a bit of crossroads because Conan CI approach is going in a different way you would like to go. So our approach is to just have Jenkins that discovers different repositories on GitLab. Each branch is built. We are using Conan install to resolve dependencies. Basically, we followed the same approach as we would go with packages in Python, Node, .NET, or stuff like that, where each package is pretty much independent from each other and underlying infrastructure. when it comes to Conan CI approach, at least my understanding of it is that it is highly aware of log files that you are using, and you as end user shall calculate full log file for your dependencies. Think 16 log files that you would like to use. Push it to CI machine in some way uh, where they are stored, and after that push, uh, packages will be triggered to be rebuilt on CI machine with these updated log files. In these log files, different options that are required will be retrieved from these stored log files, and only options you require will be built. Each package build will probably update some log files and push new log files. So we'll have some, let's say ripples going through your Conan server and rebuilding all packages in your dependency chain. Basically giving you sort of on-demand dynamic packages build. Of course, you will build only packages you require to be built, but to be honest, I think that the solution is very, very complex. It gives you dynamic dependencies between jobs. You need extra infrastructure for storing and managing these log files. And I don't understand how I would be able to use Conan server as a boundary between me, producer of packages, I would like to share with my customer and give only binaries. And I would like my customer to use just point their Conan installation to my remote and pull different packages. And with this approach, the Conan CA approach, I would need to expose some sort of service gateway where they will be able to push calculated log files, wait for packages to be built, so some sort of monitoring of CI and progress of these ripples going through CI so the consumer will know when packages are ready to be used. And Conan 2.0 was already mentioned today. I'm a bit scared about Conan 2.0 because going through Conan slacks tells you that a lot of things will break and even more things will change package ID. So I'm a bit afraid that, for example, version ranges with packages may not work anymore, or it will be much harder to use them. And with so many differences in CI approach, I'm worried that we'll need to rework parts of our solution, or I hope not, but it is possible that we'll have to rethink it from the start, how we can build our packages. I will go with, if it's necessary, I will go with rebuilding our infrastructure, just to not be stuck with Conan 1 forever, because it will be not maintained anymore. So that's the scary stuff when it comes to Conan 2.0. On the bright side, there are a lot of documentation in Conan tribe repository. I read them recently, and I think that there is a lot of, I would say, deeper insight into package management in C++. So I hope that some of the problems we already have will be solved with this new ideas and cleaned up approach. So on one hand, I'm scared of Conan 2.0, but on the other hand, I'm looking forward to it to see this deeper insight in work and maybe clean up my vision of package management. So in summary, it's need to be said that package management in C++ is not easy. There is a lot of different things affecting what you do, and you need to take into account. But Conan offers a lot of flexibility when coming to package management, so you can plug it into your development flow quite easy hopefully without rethinking everything from scratch. Preparing infrastructure is not easy thing to do. There are a lot of decisions to make, and I hope that my presentation will give you some ideas how this kind of infrastructure can be built. But once you have everything set up, you can create packages very easily. It's just creating Conan file if you CMake files, and that's all. And when you create your first project, just by combining different blocks, it's like being a child and building another Lego set. When you have standalone blocks and you combine them together to get something that moves and works, and it's quite easy, and you see something start very fast. If you can, I will advise you to disconnect yourself from Conan Center and copy required packages to your local Conan server, just to avoid serious breakages or not have to deal with recipe revisions and stuff like that. And especially at the start, be prepared to try a lot of things. A lot of things will break, some very early, something a bit later, once you get a bit more understanding of and intuition on Conan. But even with that and the pain points I mentioned, I think it's a good advice to use Conan because it's flexible, and I think it's the closest thing we have now to get package management in C++, on the same level like we have in, let's say, .NET or Node. So yeah, I think that's a pretty good step forward for the whole ecosystem. Thanks for listening. I will look through the question in the moment. If you'd like to talk about Conan or QEMU stuff or some space stuff, I will be hanging around today for a few hours more, and today and tomorrow. So catch me if you'd like to talk, or you can reach me on Twitter or by email. So let's go to the question. Why not use settings you set up in your settings part of Conan file? I don't think I understand the question. Let me go to the Conan file py, or is it more about using toolchain file? I guess it's more about why we are using toolchain file and not describe different flags as part of settings of profile or settings schema. Yeah, that was a bit of hard decision. We already had a lot of toolchain files, so it was reasonable to reuse them. And by having separate Conan toolchain files, we can easily start new CMake project without Conan if necessary on the end user project with a specified toolchain file. And in our settings, in our toolchain files, we have things like finding C compiler, assembly compiler, linker, object dump, stuff like that. Also setting up compilation flags like no exceptions or no RTTI, stuff like that. I don't think that putting that in settings file just explode the size of the profiles or settings itself. Yeah, yeah, maybe putting the all settings in settings yam is okay, but yeah, we decided to go with toolchain files. So I I don't know if that answers your question. In your common file, you don't use always and arc. Yeah, the settings that really depends if the I treat the settings defined in package as a declaration on what settings package depends. And if package is independent from OS or RTOS you are using, let's say is base64 utility, um, you don't need to depend on OS version. If your package is using, let's say, semaphores, then you depend on RTOS settings. So you will need to put RTOS here. For header only package that depends on nothing, the settings list will be just empty. The set, the compiler, bit type, and yeah, exactly. Okay, if there are no more questions, I will just say thanks again for listening. Have a good conference, and if you'd like to talk, just find me somewhere around uh, this beautiful town. Bye.